So here is your notes unit 4.8. Objectives today, or for these notes for my honors class, is to be able to solve quadratics using the quadratic formula, be able to use a discriminant to determine the number and types of solutions you will have. So the quadratic formula is basically just another method um, to use to solve a quadratic. So far we've learned factoring, we've learned taking square roots directly, we even learned graphing these things to find the x-intercepts and completing the square. So this is just another method for doing that. So it's an actual formula, so you just plug stuff in and it'll get you an answer. Discriminant, I'll show you later on what a discriminant is, but it's very closely related to the quadratic formula. It's not going to give you answers as in solutions, but it'll tell you what types of answers you will have. So you won't know what the actual answer is from finding a discriminant, but you'll know what they actually mean. And I'll show you that too. So methods for solving quadratics. These are the four main methods that you go over in most math classes. First one is factoring, square roots, taking square roots directly, completing the square, and last part is quadratic formula. All of them get you the same type of thing. Factoring is not always nice and neat. Square roots directly is not always nice and neat. Completing the square, you can almost always do that one. Actually, you can always use that one. And then so can you. You can use any of these at all times. It's just whether or not it's the most efficient way of doing it. So that's what our next section is actually beyond, is picking which one of these to use. But right now I'm going to show you how to do the quadratic formula. So where it came from. So the quadratic formula just didn't come out of thin air. It looks like this. Most of you guys should have memorized it from your Algebra 1 classes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it actually comes from this. So I'll show this real quick. Actually, it won't be real quick. It takes a little while to do this, but I showed this in class, but I'm going to go ahead and show it again. So basically what happens is you complete the square to solve this one. So to complete the square, now there's different steps you can take, but the ones I'm going to do is like this. So ax squared plus bx, and then you're going to subtract c on both sides to get your x terms by themselves, so negative c. Next part is we don't want this a right here. So to get rid of that, we're going to divide both sides by an a. So a divided by a is 1, so you're just getting an x squared plus b over ax is equal to negative c over a. All right, so the next part is that now that we have the a is a 1 here next to the x squared, we can complete the square. So you do x squared plus b over ax plus a new piece to complete the square equals negative c over a plus a new piece to complete the square. So the new piece is b over a, and then you're supposed to divide that by 2 and then square it. But to divide by 2 is the same thing as multiplying by half. So like if I wanted to take half of a 6, I could either divide it by 2 or I can do 1/2 times 6 and they'd get the same result. So since I already have a fraction here, I'm going to multiply this by 1/2. B over a times 1/2 is b over 2a. So that's the same, this equivalent of taking half of it, and we're going to square it. So the new part that we're actually adding on is b squared over 4a squared. That's because b over 2a times another b over 2a is b squared over 4a squared. So I'm going to add that to this side too. All right. So the next part, the left side is now a perfect square trinomial. So I can go ahead and use my pattern to factor that. That's an x plus b over 2a. And we learned that in completing the square section. Now this side, I actually need common denominators to put these together. So there's a 4a squared over here. I got to make this one a 4a squared. So to make that a 4a squared, I got to multiply it by a 4a, because a 4a times an a is a 4a squared. So now they have common denominators, but remember you can't just decide to multiply something by 4a. It has to be a fancy one, so over 4a. So I got to multiply the top and the bottom by 4a. So what you'll get is a, let's see here, 4a times a negative c, because there is a negative sign there. It's going to be a negative 4ac plus b squared, which is on the other side, and everything over 4a squared. Now, if you notice, we have negative 4ac plus a b squared. Quadratic formula says b squared minus 4ac, so I can actually switch these around because you're adding, this is commutative, so you can flip it around just to make it look more like our quadratic formula, b squared minus 4ac. So I'm going to consider that part b squared minus 4ac. All right, so we're getting there. Now I'm going to square root both sides. Now, just a reminder to my class, you will have a problem like this on the test. So it is good to know what's going on here. We get x plus b over 2a. So when you take the square root of a fraction, this is a fraction, square root of the top and the square root of the bottom. Square root of 4a squared is 2a. So the bottom part, you only get a 2a. Up top, when you take a square root, you get a plus or minus. And then that stuff just stays inside of the square root. B squared minus 4ac. As you can tell, this is starting to look more like the quadratic formula. Last part is I just need to subtract this b over 2a part. So minus b over 2a minus a b over 2a. You have common denominators, so you can just do this stuff minus this. Okay, but so this is like a negative b, and you can write this part second. So that's what I'm going to do. X equals, I'm going to write the negative b first, and then I'm going to write the plus or minus square root of b squared minus 4ac all over 2a. That's where the quadratic formula came from. Some guy just didn't come up with it out of the blue and said, hey, this works, but he actually took this, applied a method we know to solve, and then came up with this formula, so he knew this formula would work every single time. Okay, so that's where it came from. And like I said, you will have to show me that on a test. So use solve quadratics in standard form. So it does have to say ax squared plus bx plus c equals 0. You need one side to be a 0 for this to work out. And then quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. Different ways to memorize that. There's songs and all kinds of other stuff. So let's go and try this out. First off, we need to find a, b, and c. One side has to be 0 for this to work. So we need to make this side a 0. Minus 5 equals 0. That means your a is a 2, your b is a 1, and your c is a negative 5. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I do want you creating your structure like this where you put blank spots anywhere we're substituting in. So negative b is a negative, your b's are 1s. So that's first one's a b, this one's a b squared minus 4ac. So a is a 2, c is a negative 5, all over 2a, which is a 2 right there. All right, so at this point, it's just a matter of making sure you plug it in correct. And from here on in, it's just a matter of order of operations. So you can do this part, and then I always suggest doing the stuff inside of the square root. Make sure all the multiplication comes first, and then the bottom part also. So this shrinks down kind of fast. So it's going to be x equals negative 1 plus or minus the square root of. So the 1 squared is a 1. Negative 4 times a 2 is a negative 8. Times a negative 5 is a positive 40. 10, yeah, so positive 40. All over 2 times 2, which is a 4. All right, and next part equals negative 1 plus or minus square root of a 41 over 4. Some teachers like you to leave it like this. I'm okay with you leaving it. Well, actually, I want you to separate them. Now, I've seen this done different ways. Negative 1 over 4 plus or minus the square root of 41 over 4. I would like for you to split it apart like this. Now, some teachers are okay with this, but I'm not. So I want you to do this. Now, actually, I shouldn't have boxed that. Sorry. Let's take those away. Delete. Because I want you to split this apart one more time. So x equals negative 1/4 plus the square root of 41 over 4. Or x equals negative 1/4 minus the square root of 41 over 4. And that's how I want to see your final answers. Okay. So yeah, that's basically how you use a quadratic formula. Make sure one side turns into 0, and then just plug it in and do it. So I'll do one more of these. Let's see here. Let's see. Let's do this one. Okay, so example 4. So I'm just doing 2 examples because basically they all end up being the same thing. Now, it doesn't matter which side you put the x's on and everything on. You could actually move all these 2 terms to the right or these 3 terms to the left. It doesn't matter. You should get the same answer either way as long as you're plugging it in right. I'll go ahead and move all this stuff over. So I'm going to subtract an x squared, add a 2x, and subtract a 4. So same thing over here, minus an x squared plus a 2x and subtract a 4. So these are gone. They're 0. Make sure you combine like terms over here. So 2x squared with a negative x squared is going to make an x squared. 2x with an x is going to be a positive 3x, and then you're going to subtract a 4. Now, the reason why the second part says what method might have been more efficient is because this is actually factorable. You can factor this into x and x. Factor the 4 is going to be a 4 and a 1. Make up that 3 plus 4 minus 1. All right, and then from there you can see that your answers are negative 4 and positive 1. That's probably a more efficient way because you didn't have to go through the whole quadratic formula. So this is not always the best way to solve something, and that's going to be the point of our lesson tomorrow. But for today, I told you to use the quadratic formula, so you're going to have to use it just to practice with it. So A is a 1, B is a negative 3, and C is a positive 4. Oh, how did I come up with that? That's wrong. Haha, just kidding. B is a 3, and C is a negative 4. That's my math joke for today. Yeah, Mr. Aguirre's wrong. That's so funny. Like that would ever happen. So x equals negative b plus or minus square root of square root minus 4ac all over 2a. Main reason why I want you guys doing it this way first also is because a lot of times people mess up with their positive and negative signs. So I wanted to make sure that you get the positive and negative signs in here that are supposed to be there, and then plug all the numbers in later. So here we go. So B, B, A, C, A. B, B, A, C, A. B squared, negative B plus or minus B squared minus 4AC all over 2A. Okay, now let's go ahead and start simplifying the right side. Technically, it's already solved because x is by itself, but you just got to simplify the right side. So negative 3 plus or minus square root of 3 squared is a 9. Negative 4 times 1 is a negative 4 times a negative 4 is positive 16 all over 2. It's going to equal negative 3 plus or minus 9 plus 16 is a 25 all over 2. Now, there is actually a square root of 25. So this is one of those instances when we actually get an answer that's not all funky looking. So now is where you split it up. So x equals negative 3 plus 5 over 2, or x equals negative 3 minus 5 over 2. And you should get 2 answers here. Negative 3 plus 5 is a 2 over 2, so x is equal to 1. So negative 8 over 2, so x equals negative 4. And there you go. Those are your 2 answers. So that's how you use the quadratic formula. Just make sure one side's 0, plug it in, do it out. All right, so the next objective part was about the discriminant. Now the discriminant is actually a piece of the quadratic formula that will tell you how many answers you will have and what type. Now the piece of the formula that it is actually this b squared minus 4ac part. This is called the discriminant. The reason is because you're taking the square root of that. So if you think about this, if you have a square root of a positive number, any positive number, what's going to happen here is that you'll have two answers because you'll have a plus or a minus. So you can actually take the square root of a positive number and get two answers, a positive of that and a negative of that. Now, if you do the square root of a 0, now any square root of 0 is 0, doesn't matter what's on the outside, because you can have a plus or minus 0. That doesn't mean anything, that's just 0. So that's when you have one answer. And then the last situation is when you have a plus or minus square root of a negative number. This is a positive number, that's a negative number. Negative number means that you're going to have plus or minus the square root of the number, and then you're going to take out an I. So actually you're going to have two complex answers. You'll have a positive answer and a negative answer, and then you'll get that, okay? So that's what I mean by over here. Two real numbers happens when you have a positive. One real happens when you have a 0. Two complex happens when you have a negative number in there. All right, how many and what type of solutions do the quadratics have? So let's do these real fast. Now, you don't have to do the entire quadratic equation. You just need the b squared minus 4ac part, because that's the part that's inside of the square root. That'll tell you if you have imaginary parts or no imaginary parts or 0. So that's the only part we're really focused on. All right, so the a part is a 1. The b part is a -6, and the c part is a 10. So b is a -6 squared. So b squared minus, whoa, that's an equal sign. Minus 4 ac, a is a 1, c is a 10. So b is 36 minus 40 equals -4. So I don't know what the actual answer is. -4 is not your answer. If you plug in a -4 here for your x's, you're not going to get a 0. So what I do know, though, is that when I do the quadratic formula, I'm taking the square root of this, which means it'll turn into the square root of this, which means that I'll have a square root of a negative number, which means I'll have two complex answers because it's negative. So if you have a negative discriminant, if you have a negative discriminant, that means you'll have two complex solutions. All right, and here, let's try this one. The same thing has to be equal to 0, just like with the quadratic formula. 1, b equals 6, c equals 9. So b squared minus 4ac is the part we're worried about. So it's a 6 for ac. So 36 minus 4, 27, 36. And that's going to be a 0. So if you think about this being under a square root, so you should always be imagining a square root here. For example, over here, you can imagine a square root over that. I've even seen some students actually leave it under a square root just so that they can kind of better visualize what this means. When you get the square root of the negative, that means you're going to have I, which means you'll have two complex. If you take the square root here, square root of 0, even if you have a plus minus square root of 0, that's still just 0. So this is one solution, one real solution. So, right? And then if it was just a regular old positive number inside of there, you would have that. So go ahead and go to the IXL website. Go to the Algebra 2 tab. I want you guys doing 4 problems from J9. That should be the quadratic formula stuff. And then 4 problems from J10, which should be the discriminant stuff. And then bring it in tomorrow, and then that's it. Okay? And bring me any questions if you have them. And obviously people have different questions because they're getting different problems, but still, we'll go over them. Okay, bye-bye. Bye.